Hi, we are Group 13 and we have created Android personal assistant application which tracks the user location every hour and use this information to predict the user's location in the next hour. Also, our app shows nearby restaurants and offers based on the user's shopping preferences. We predict the future location by using machine learning algorithms. We tested our database with naive Bayes, support vector machines, and decision trees, and found out that decision trees provide the maximum accuracy in our case. Hence, we choose decision trees as our main algorithm. This is a smart component of our application. Also, we have not used the Google login API as we needed to set up our own server to suggest offers based on the user's shopping preferences. We set up an Amazon EC2 server which handles login, register, and shopping preferences API, which will be discussed in the later part of the video. This is our login and register screen. The user can either log in or register as follows. Okay, we are now fetching the user's current location. This is the main UI for our activity. This includes list view for suggested offers, nearby restaurant, weathers, and user preferences. This covers task 6, main app UI. We'll first cover the user preferences. The user can set his shopping preferences by checking any of these options and confirm them. This covers task 5, UI for preferences. These preferences are stored in the database. When the user clicks on the offers tab, he is redirected to the offers page. We fetch the user preferences from the database and pass this as a query to our server. The server returns the suggested offers to the user. This is done by our web crawler, which we program to crawl through shopping websites and get the sales offers. This covers task 2, server setup API, task 9, web crawler, task 18, UI for suggesting offers. On tapping any of these offers, we present the user with different sharing options. This covers task 20, share offers. When the user taps on the restaurants tab, he is redirected to the restaurants page. We fetch user's current location and show nearby restaurants using Google Places API. On clicking a restaurant, we show a Google map with the user and restaurant's location using Google Maps API. This task covers task 13, track user's current location and Google Maps, task 16, restaurants API handler, task 17, UI for suggesting restaurants. When the user taps on the weather tab, he is redirected to the weather page. We fetch user's current location and give current weather using the Yahoo Weather API. This covers the following tasks: task 14, weather API handler, task 15, UI for weather. Now we will discuss the notification handling. This notification shows user's predicted location in the next hour and suggests weather forecast in that predicted location. We get this by doing the classification using decision trees. We also track the user's location every hour to maintain the database. This covers following tasks: task 7, notification handler, task 8, UI for notification, task 11, push notification. Task 12, track users' activities, that is time. Task 19, suggest weather forecast activity. Now we'll show the database setup. It has two tables, one for personalization and other for preferences of every user. In the personal table, we store users' location, day, city, latitude, and longitude. In the preferences table, we store the user's preferences for shopping, such as clothing, footwear, etc. We use these tables for our machine learning datasets. This covers following two tasks. Task 1, database setup, and task 10, personalization. Now we will discuss the server side of our application.
Hi. We've configured our server on Amazon AWS EC2 instance. This is our public DNS IP address. We have currently configured it, and this is our SSH. We are SSHing to a particular server to deploy and run the server. So if you look at it, this is the required IP address, and this is the same one over here. We have configured our login, register, and offers API all on our server. Now I'll show you some login actions that's happening. Now, for example, this is the current login. If you have a clear look at it, the username is being written and the password is being written. Now, if you see, it's a successful login. Now, if you change the password, it says check username or password. The same thing, we've done all kind of checks for password and username here. This is the registration API that we have implemented. Now, if you have a look, this user's already been registered. Now, if we run the same registration API, it shows that the username has been taken. Now, for example, if I change it to user3 and this, so we have successfully registered the user. Now, I'll be handing over my talk to Jetti, who's going to talk about our web scraper.
Hi, we have implemented our web scraper using Scrapy framework. What this web framework does is it crawls through a set list of websites and it fetches the basic topics which are of interest to us, such as the offers or any movies or any sale, and it populates them on a server in a fixed location. So whenever we need those offers, meaning whenever the user queries for the offers, and he can just hit this endpoint and you can clearly see that the offers are being sent.
This covers three of our tasks. One is task 2, task 9, and task 19. Task 2 is server setup. Task 9 is a web crawler, as Jetti explained it, and task 19 is suggestion based on user preferences. For example, if you have a look at the particular API calls, this is a server PI. The API calls, the particular user can give the preferences, and we do web scraping based on the preferences and return back the results to the Android app. And we've given a thorough explanation of how that works in the Android app. And this is the API for user login and user register, where we implemented all the successful and failure calls. Hence, we've implemented all the tasks that we have suggested on the proposal. We implemented all the 20 tasks. Thanks and goodbye.